Hello, this is Dr. Morsi, and today we'll be talking about arithmetic operations. The first example will be decimal subtraction. As usual, we go over a decimal example, and then we continue on with covering it in other number systems. If we look here, we have 4,258 minus 3,519. So as usual in any subtraction, we start with the rightmost column first. We see here we have 8 minus 9. That doesn't work, so we have to borrow from the previous column. So one way we could do this is we cross out the 5 on the top. We make that 4, and we take that 1 and make the digit next to it into an 18. We take it as a 10 because that 5 is in the tens column. So we cross it out, make it a 4, and take it a 1, and that's an 18. 18 minus 9 is a 9. Then we look at the next column. That's a 4 minus 1. That gives us a 3. Of course, again, decimal, we know decimal, so that's an easy calculation for us. Then we look at the next column. That's a 2 minus 5. That doesn't work. Again, we cross the 4, make it a 3. Take that 1 as a 10, so that's a 12. 12 minus 5 is a 7. 3 minus 3 is a 0. Pretty easy. So all these up here are our borrows. Or we need to look at this in another manner, and we need to look at it in another way because we're going to be dealing with this new way in our other number systems. So we look at the same two numbers, and we want to do our subtraction. But with the first one, 8 minus 9 doesn't work. I want to add a digit to the bottom instead of borrowing it from the top. It's the same principle. Instead of borrowing a tens from the 5 on the top, I'm going to add a digit to the bottom. Same thing. On the top, 4 minus 1 will give me a 3. When you think of the bottom version, right down here, 5 minus 2 will still give me a 3. So it's the same principle. I'm still doing my manipulation in the tens column. So when I add it to the bottom, I take it also still as a tens and make an 18 to my first column. So 18 minus 9 gives me a 9. Then in my second column, 5 minus 2 is a 3. So there's my 3. Again, 2 minus 5 doesn't work right here. So I go ahead and borrow, but by adding 1 to the bottom, carrying it up here as a 1. So now it's a 12. 12 minus 5 is a 7. Now I have a 4 minus a 4. That's a 0. So you see the same, and up here are my borrows. But I borrowed them from a different place. I borrowed them from the bottom. I added them to the bottom to borrow them up top. So I got the exact same response, but in a different way. So now let's look at binary subtraction using the second method. Okay. Looking at the first column, I have a 1 minus a 0. That's easy. 1 minus 0 is a 1. I look at 1 minus 0 again. That's a 1. 0 minus 0 is nothing. 1 minus 1 is a 0. Now 0 take away 1 doesn't work, so I'm going to add a 1 here and take it up there as a 1, 0, which is a 2. 2 minus 1, because 1, 0 over here is a 2. 2 minus 1 is a 1. Now over here in this column, 1 minus 1 is a 0, and then 1 minus 1 is another 0. So you see when I borrow from the bottom, basically, because this is if I'm borrowing from the bottom number, it makes life much easier for me when I get into the other number systems. In decimal, it's easy when I borrow from the top because I understand decimal very well. When I borrow from different number systems, it's much easier when I borrow from the bottom number. Now let's try it in octal, because again, as I go up in the number systems, you'll see that it's much easier to do it the new way. I'll look at the first column. 3 take away 0 is a 3. 0 take away 2 doesn't work, so I'm going to do the new way. I'm going to add a 1 under the 5, and I'm going to take it as a 1, 0. 1, 0 in octal. 1, 0 in octal is actually 8 in decimal, right? Because I'm rolling over. The octal numbers are 0 to 7 is the maximum number. So 1, 0 would be 8. So I'm going to do 8 take away 2 will give me a 6. So that result is a 6. So now I have a 7 minus these two together, which is a 6. That will give me a 1. Now my next column is a 3 take away 7. That won't do. So I'm going to borrow from down here. I'm going to add 1 down here and take it up as a 1, 3 in octal. So 1, 3 in octal is actually an 11. Why? Well, sorry, yeah, 11 decimal. Why? Because 1, 3 in octal, 1, 0 is an 8. Add 3 to it will make it a 11. So 11 minus 7 is a 4. So that would be the result down here. So there's a 4. And then you have the next column, 1 minus 1 is a 0. And that would be your answer in octal. So that would be how to do subtraction in octal. And those are my borrows. Next, let's look at multiplication. Again, we will start with decimal to show how it's done, and then we'll move on to the other number systems. As we can see here, we have two numbers that we are going to multiply together. I am going to be showing multiplication in a little bit of a different way as we do it, just to show the method that we would use with the other number systems. So this is 123 multiplied by 45, and 123 multiplied by 45. The way you do multiplication is you take the first digit, multiply it by the number, first digit times 3, then first digit times the 2, which is really first digit times the 20, and then the first digit 5 times the 1, which is really first digit 5 times the 100. And then you take the second digit and do the same thing. So it's 4 times 3, 4 times the 2, which is really times 20, and 4 times the 1, which is really times 100. And then you take the results and add them together. So when we look at the 5 here, 5 times 3 is supposed to be 15. So that's what we put down here. And then the next number should be 5 times 2, but it's really 5 times 20 because it goes in one digit. So we append the 0 right here, and 5 times 2 is a 10. So either you say 5 times 20, or because you're shifting in one digit and you're multiplying the 5 by the 2 and you know you shifted in one digit, you add the 0 right here, and then you say 5 times 2 is the 10. Because it's in decimal, we know we're doing 5 times 20, and we know that it's easy to say 5 times 20 is 100. So we could just say 5 times 20 and 100. In another decimal system, you can say 5 times 2 and figure out the number, and know you have to move in one digit, and that digit has to be a 0, and you put the 0, and then you multiply 5 times 2 and add just the 10. Now, for the next one, it's 5 times 100. So you go in and you say 5 times 100 is 500, or you could have said 5 times 1 and appended 2 zeros because you shifted 2 zeros to multiply by the 1. Now for the 4, here I had to go in one digit. I shifted one digit to take the 4, so I could have appended the 0 right here, and then 4 times 3 is 12. Or I could have just then done 3 times 40, or 40 times 3. 40 times 3 to get the 120. Next one would have been 40 times 20, or just the 0 and the 0, appended them and done the 4 times 2. And then the last one, it could have been 40 times 100, or appended 3 zeros and done the 1 times 4. So see, there's two ways of thinking about this to get the final answer, or the multiplication parts of the calculation. And then finally, you add every column together, all the columns together, all the numbers in the column. So this is just, all these are just a 5. Here you have a 1 plus a 2, which gives you a 3. Here you have 1 plus 5 plus 1 plus 8, which gives you a 5 plus a 1, and then 15 basically. So you have a 1 carry, and 1 plus 4 is a 5. And that would be your final answer here. And that's for a decimal number. Now you want to look at binary multiplication. And with binary multiplication, here are your 4 options for binary multiplication. And when you look at these options, you need to consider these 3. And when you look at them, you'll see that 0 times anything gives me a 0. So that's a quick way to remember it. 0 times anything gives me a 0. And the only time I'll get a 1 result is if I have 1 times 1. So that's a quick and easy way to remember it, right? 0 times anything, which is in regular math. In our regular math, when you multiply 0 by anything, you get a 0. So in binary, it's the same way. 0 times anything is going to give me a 0. In any number system, really, is the same thing. When you multiply 0 by anything, it's going to get you a 0. And 1 times 1 will give you a 1. So here's 2 numbers that I want to multiply together in binary. The way you do it, you take the first digit, multiply by the whole number. Then you take the second digit, multiply by the whole number. But every time you take a digit, because you're shifting, so you shift 1 in, and then you enter the number. So here's the first number, multiply it, enter it. Second number, multiply it, and shift it in, and then put the number down. Third number, you multiply by the top number. Because it's 0 times the number, it's a 0, and you shift and enter. Fourth number, you multiply, shift and enter, and so on. You always shift in 1 and then enter your number as is. Because 1 times anything is the anything, again, I'm going to repeat that. 1 times anything is the anything. So whenever we have 1 times a number, you put down the whole number. Whenever you have 0 times the number, you put down 0. And every time you multiply a digit by the number, you shift 1 in. It's as if you're adding a 0 at the beginning and just writing it down, but instead of adding all those zeros, we're just shifting the number in 1. Then once we're done with all this, we add all the columns together. So I should have 1, 2, 3, 4, 5, 6. I should have 6 rows right here. And here I have 1, 2, 3, 4, 5, 6 rows. I have 1, 2, 3, 4 ones. So I should have 4 copies of the first number written down here, which I do. And I have 2 zeros, so I should have 2 sets of zeros, which I do. After I do that quick check, I realize, okay, now I have my numbers. I can start adding. So here's what I do. I add the numbers together, which means I look at my first column. It just has 1, 1, so I write it down. Then I look at the second column. It has 1, 1. I write it down. Third column, 1, 1. Write it down. So I'm adding the number of ones in my column, figuring out how many they are, and then I'm putting down the binary equivalent of that number in my results section. Third column, only 1, 1. So I put it down. Now, this column has 1, 2, 3 ones in it. Okay? So what is 3 in binary? 3 is 1, 1 in binary, which means I put a 1 down and I take a 1 as a carry. So I put 1 down and take the 1. I see here it's 1, 1. So this 1 goes down as one of my sums, and this 1 over here goes up here as a carry. Then I take the next column and I add all the ones up. I have 1, 2, 3, 4, 5. So I have 5 ones. 5 ones is equal to 1, 0, 1 in binary. So what I do is I take this first digit, put it down as a sum. Then I have the 0, which is right here, goes up here as a carry. Then I have the last one, which is this, goes up here as a second carry on the next column. So when you look over here, there's a 1, 0, 1, which is my 5. Because these orders of magnitude have to be represented as I write down my sum of these 5 ones. So there's my 1, 0, 1, and that's how it's done. Then I highlight the next column and I realize I have 2 ones. What's 2? It's 1, 0, so I get a 1 and a 0. So I put 1, 0. Then I highlight the next column and I have 1, 2, 3, 4 ones. What's 4 in binary? It's 1, 0, 0. So the rightmost digit goes down as a sum, then the next 0 goes up as a carry, then the next 1 goes up as a carry on the next column. Highlight the next column, it's 2 ones. 2 ones is a 1, 0. Drop the 0, carry the 1. I have 4 ones again, that's 1, 0, 0. Drop the 0, carry the 0, carry the 1. 0, 1 is only 1, 1. And then a 1. And that's my final answer. So it's very systematic. Look at each column, add the number of ones, figure out the binary equivalent of that number, and then make sure you put the carries on the right columns. That's critical. So now looking, what is the multiplication table for octal? This is the multiplication table for octal. I don't expect you or anyone really to memorize this table. I mean, people can memorize it if they want to. I certainly don't. So there's a multiplication table for octal. I would keep this handy to take a look at it. Some professors might require their students to memorize it. I'm not one to expect students to memorize things like this. I expect people to keep more important things in their brain because anyone can reference this online or anywhere. So here's the multiplication table. Now, let's say I wanted to do these 2 numbers and they're octal and I wanted to multiply them together. So I have 2, 1 in octal multiplied by 4, 6 in octal. So the first thing I want to do is multiply the first 2 digits together. So I have 1, 6 that needs to be multiplied together. So the first thing I'll do is I'll look at the 1 in the octal table, multiply it by the 6, and the result is 6. So I put down 6. Then I shift in and add a 0, and then I'll take the 6 and multiply it by the 2. So then I'll take the 6 and multiply it by the 2, and the answer is 1, 4. And I add that 1, 4. You see how shifting and adding the 0 makes sense now? Whereas in decimal, I could just multiply by the 20. I can't say 20 in octal because 20 doesn't exist in octal because we're not dealing with decimal, right? Then I'll look at the 4 and the 1. So I'll shift and add 0. And then I'll say 4 times 1 is a 4. And I'll put a 4. Then I'll deal with the 4 and the 2. Both are higher order digits, so I'll shift and add 2 zeros. And then I'll do 2 by 4 is a 1, 0, and I'll add the 1, 0. Now I add all the columns, but I'm adding them in octal. And adding in octal is different, right? Because octal goes 0 to 7. So it's very important that we pay attention that we go 0 to 7. Anything above a 7 rolls over to 1, 0. So 6 plus 0 plus 0 plus 0 is a 6. 4 plus 4, if you look on the bottom here, 4 plus 4 in octal is 1, 0. So it's 0 and a carry 1. And you see the carry 1 up here. 0 carry 1 because the calculation is shown down here. And then 1 plus 1 in octal is a 2. And then the 1 goes down. So the answer is 1206 in octal. And that's how you do octal multiplication. And you do a similar process for hexadecimal multiplication. Now division, that's, you know, long division is a whole nother story. So this is long division in decimal. Again, we try everything in decimal first, and then we move on to other number systems. So the first thing you do in decimal, you look at the number that you're going to divide, and so this is 5356, and you want to divide it by 24. So you look at 24 and you see how many times does 24 go into 5. Does it work? No. So then how many times does 24 go into 53? Does it work? Yes. How many times? Twice. So then you take 2, multiply it by 24, it gives me 48. Then you subtract 48 from 53. That gives me a 5. So as soon as you do the subtraction, you drop the next 5. That gives me 55. Then you look at 24 again. Does it go into 55 wholly? Yes. How many times? Twice again. 2 times 24 is 48. Do another subtraction. What does that give me as a result? A 7. Then I drop down the 6 again. Now how many times does 24 go into 48? 3 times. 3 times 24 is 72. Do a final subtraction is a 4. So the result is 223 remainder 4. Or if I wanted to, I could have started adding a decimal point up here, decimal point up there, 0, 0, and dropped the 0 and continued on with decimal points. So that's how you would do a long division in decimal. Now let's see how we do the same thing in binary. What's important in binary, because in binary at a glance, you need to kind of figure out, will this number go into this number wholly? Now, the way to figure this out is, because this is ones and zeros, you look at the most significant bits and you say, well, these are ones, this is a 1, 0. So clearly, this number is bigger than that number because the most significant bits are ones, the most significant bits are zeros, based on the number of digits. So the first thing you're going to say is, well, does this go into the first digit? Of course, no. Second digit? Of course, no. First 3 digits? No. First 4 digits? No. How many digits is this? 6 digits. So you go into up to 6 digits and see, can this number go into the first 6 digits? And the answer will be no, because the first 2 digits here are 1 and the first 2 digits here are 1, 0. So there's no way this number can go into this number wholly. This number is bigger than that one. So for that reason, you need to look into, you say a 0 up there at the 6 digits. You put a 0. And then you take the 7 digits. And then immediately, if the answer was 0 at 6 bits, then the answer will be 1 at 7 bits. And then you take the 1, multiply it by this number, and you put it down here, because 1 times a number is the number. And then you do a subtraction, and the subtraction is binary subtraction that we're used to. You're going to have to do the borrows like before. We're not going to go into detail here because this is a division problem, not a subtraction problem, so we're not really going into how the subtraction is happening. And this would be your answer. Now, you're going to take these 6 bits and say, I have 5 bits here. So clearly, well, first of all, when you do the subtraction, you've got 5 bits. You have to drop the next bit down. So now you have 6 bits versus 6 bits. There's 111 at the beginning here. There's 110 here. Does this number go into this number? No. So I'm going to put a 0 up there, and I'm going to drop the next bit down. And the reason I say no is because there's 111 up there, and there's 110. Clearly, this number is bigger than the 6 bits down here. So I had to drop a 0 to make sure that this number could go into this number. So then I put a 1 up there and multiplied by this number, drop it down here. Now I do the subtraction again, and this is my result. Again, drop the next bit. Now I have 7 bits over here. Clearly, when I have 7 bits, this number will go into this number. So I go 1, multiply, drop it, subtract, drop the next digit. Just so happened that it's exactly equal to that number. 1 times the number gives me this, and I get an even 0. If I did not get an even 0 and I continued on, I put a decimal point and I keep going. For octal division, you can go ahead and look at this example. We can work through this one. We have 4163 divided by 25. So we first look at, again, the first 2 digits into the first 2 digits of the 4163. 25 can't go into 4. So we look at 25 going into 41. 25 is less than 41, so that would work. So it can go into it once. That's pretty obvious. So we'll go 1 multiplied by 25 is 25. You can then do the subtraction, like I showed you how to do subtraction in octal. But here's an example of how to do it here quickly. 1 minus 5 doesn't work. We borrow. That's a 1, 1. So 1, 1 in octal minus 5. So 1, 1 in octal is 9. 9 minus 5 is 4. That gives me the 4. 4 minus 3 is a 1, and that's the answer there. And I'm not going to do it for all the examples, but I'm just showing you for this part of it. So that's a 1, 4. We drop the 6. So now I have 2, 5 into 1, 4, 6. Of course, to be able to get the rest of these answers, you'd need the multiplication table with you to give you how to figure out how many 25s go into 146. How many 25s go into 16? I should say 25s. How many 25s go into 146? And you would need to look at the octal multiplication table for that. One easy way to do it is take 25 in octal, add it to another 25 and see what the result is. Add it to another 25 and see what the result is. And that's a quicker way to do it instead of trying to do multiplication. So you take 25, see how many times they go into 146, and you'll see 4 times. So if you add 25 4 times, you'll see it goes into 146, and it gives you 124. You subtract that, and that gives you 2, 2. You drop the last 3. How many times does 2, 5 go into 2, 2, 3? Well, you knew 4 times gave you 124. Add another one, and another one, and another one, which makes it 7, and that gives you another 2, 2, 3, and the result is 0. So the final answer is 4163 divided by 25 in octal gives you 147 with a remainder of a 0. So those are all the different arithmetic in arithmetical operations for all the different number systems. And again, I went over binary, decimal, and octal, but the same would apply for hexadecimal. It's just a different number system. The same processes apply. And that's it for this topic. Don't forget to sign up for the channel, Dr. Morsi's Tutorials, and I'll see you next time.